Hi everyone, this is for your assignment that's being posted about neutralization and water and pH. So we're sort of wrapping up the entire unit with these last three topics that you need to know. Now, first thing, neutralization reaction. If you have your brightly colored sheet of paper at home that has all the different types of reactions, this should go on there. Neutralization. What we have is a general format of acid plus base yields water and salt. So you're going to mix an acid and a base, so something from those two tables. Every single time you're going to get water and salt. Remember, salt is that ionically bonded compound. It is also a double replacement reaction. AB plus CD yields AD plus CB. Now, there's a little reminder because some students don't see it. If water is part of either the acid or the base, if it's acting as one of those, it can be written H2O or HOH, or to make it seem a little easier to see whether it's an acid or a base, it is the same as a hydrogen ion plus a hydroxide ion all bonded together. We really only do this for acid-base reactions, but it might help you see it. Over here we have a little animation of hydrochloric acid plus sodium hydroxide, and they rearrange. We end up with water going off one side and our salt of NaCl going off the other. Okay, so interpreting pH. pH is measuring how much acid there is. That acid is going to be in the hydrogen ion or hydronium ion in the solution. The more acid, the more acidic, which makes sense, which means the lower the pH. So please be careful of that. Now down here, we have this great little diagram. The lower the pH, the more acid. The higher the pH, there is still acid there. Remember that. It doesn't completely go away. It's just that there's a lot less. And that hydrogen ion is always balanced out with our base of hydroxide ion. So when we've got a really basic solution, we have a lot of base and only a little bit of acid, but our pH is completely based on our hydrogen ion scale. So when our hydrogen ion is 10 to the 0, that means we have a pH of 0. When it's 10 to the negative 7th, that means it's a pH of 7, which is one of the things you're going to be doing next. I'm going to read this to you and add a few little things. pH is the positive molarity exponent. So when our concentration of hydrogen or hydronium, right here where I'm underlining, is 10 to the minus 7th, the exponent of the acid concentration is minus 7, which is up here. That's the exponent. So to find the pH, we take the absolute value of that number. So if our hydronium concentration is 10 to the minus 7th, our pH is 7. If we're not given hydronium concentration, we're given hydroxide. Now remember, hydroxide is our base. We have to add one more step. So we still are looking at this exponent, 10 to the minus 2. So we find the exponent, which is a minus 2. We take the absolute value of it, 2. Now that's not the pH, that's the pOH. So we have to subtract it from 14. 14 minus 2 is a pH of 12. Now you're going to be finding pH and pOH. To find the pOH, because this is hydroxide concentration, we just use this number, the absolute value of it. But that's what you're going to be doing in your work, and this wraps up our unit on acids and bases, neutralization, table M, table L, table K, all of that. If you have questions, hit me up with an email. I will respond as soon as I can, okay?